Not a mess, but we made a total standard payload. Now I'm just adding what I'm missing on there. But I guess yeah, I'm missing the extender cable.
But that's only required for the weather shield, and that looks very complicated for the standard payload. Can I see it?
Well, this is for all three payloads for August. It's a total system score.
There are only 2 payloads for August, boys and girls. So the data shield presumably doesn't need the multiplexer ADC. Presumably the data shield is set up so it works by itself. Right? That's a question. Have you looked at the
data shield? Okay, ask me again.
The weather shield.
Mm-hmm.
Presumably that works by itself.
Well, we're considering it a sensor.
I understand, but if you had a 1 shield stack on the Arduino Mega, the weather shield and the Arduino, and you use the single RS-232 connection in the Arduino to produce the output, would that work?
I think it would work.
Yes.
I mean, the question is, does the weather shield doesn't require a separate MUX and ADC?
No, it doesn't. It doesn't necessarily. That's why we were gonna combine it with Rachel's VLF and put them on to transmit her VLF.
Hopefully her VLF will be ready. I'm dubious, but so the Arduino is powered by a battery, which has a presumably by this point known voltage and current requirement.
We're doing that.
That was the wrong tense. You should already know that.
I have it in the notes.
Now, the weather shield, does it require additional voltages? Does it, for instance, require plus and minus 15?
I don't know. I'm working on it.
I mean, you shouldn't be working by yourself, okay? There's a whole team in this picture.
If the chart's on Google Drive, I don't know if it's up right now. You can check it.
It's my binder over there. I should have it.
I mean, this is something you figure out very early in the design process. We should not be asking these questions at this point in time. These answers should already be known. That's why I put this enormous chart up there of all the power requirements, and why I was a little baffled when you said, I don't know why do you think there are things missing? There were empty boxes. But for most of these sensors that I'm familiar with, you usually need more voltage than just +5.
Right. I have a voltage sheet.
And by this point, we should know, does the weather shield require, you shouldn't be looking it up now, this is not, but it should be, that should have been yes, or either a yes or no answer at this point. And it shouldn't be just Erica. Somebody else should be helping her on this.
I'm pretty sure the weather power off there.
Only.
That's how I assume also works, but
You cannot assume. You must check. You must always, and it should have been checked earlier in the design process. Very early, weeks ago.
I have the power team right now and the software team. Well, they are working on checking all the parts, making sure they're turning on, things like that. We haven't necessarily put anything together. We're doing the little checks right now.
But the ordering the batteries is really key because they're lead time items. And so you sit and you do that on paper when you first order the parts. You don't have to wait for them to come in. Once you have the order placed, the spec sheet tells you what you need to know. And so I should not be staring at blank stares. Diego says he doesn't think it does. But you guys should know this. These are crucial pieces of information. We should know for each of the payload configurations what the voltage requirements are. There are most of these instruments, for instance, the VLF requires plus and minus 15. So you will need a battery stack, but non-regulated. So you'll need a battery stack, and it's very, very low current. Okay, so once you know what the voltages required are and the current for each voltage, you can then specify the batteries. Now, hopefully, most of this can be done unregulated. Or if it's being done regulated, you can buy the kind of battery I have in there, where the regulator is buried in the battery. And that's a little bit of a defeat for me. You guys should be able to do series pass regulators in your sleep. Yeah, I mean, you know, it's expectations based on 40 years of dealing with students who could do this.
Something you should have put on the application.
Yeah, I remember I lost a graduate student about 20 years ago because I expected, up until that point, every graduate student I ever had, you ask him to build a DC power, a plug into the wall DC power supply, and you get one back the following day. This guy kept saying, why can't I just buy one? And that may actually reflect a change in price and reliability structure, that it actually was practical to just buy one, but I'm very much into the you build it yourself dude mode, particularly when dealing with graduate students, and no. He said, I don't know how. You're a graduate student of physics, of course you know how.
Just to solder the ends of one to another.
No. Building it, to build a DC power supply, you first connect the wall AC into the relevant transmitter to produce the voltage you need, or 1.4 times the voltage you need. Then you use a diode bridge to rectify the AC output of, and then you apply a humongous filter to kill the ripple. It takes a couple of hours.
We've done that in lab. I wouldn't think to do that ever. I've done that before. I just wouldn't think to do that if you told me. If you told me to build a DC power, so that's not the first thing that would go in my mind. That's why I'm taking the class over here.
Yeah. Okay, so the 3.6 volt regulator worries me. I may even be willing to fly an actual breadboard just to get that done. But it occurs to me that the vendor who sold us the transmitter probably has something to say about this. They may have appropriate batteries. Has anyone asked?
For the vendor, no. I just ordered the transmitter.
But did you go to the website and say batteries to go with this transmitter?
No. I was leaving that for the battery team.
Facepalm. Well, the battery
Yeah,
team
the
should have
power
done
team.
that.
No.
That's the first place to start.
Makes too much sense.
See, I do have the book, and like for the transmitter, I have all the information on it. And it's in a book and it's in a packet. I just hope that power team would look at it. But if not, I'll do it. It's no big deal.
Eric, just send me the.
All at this point, all of the PDF, the technical specifications of everything we buy, go two places: in a loose leaf binder that sits in 532, and on your shared drive. Should already be there, right? So now if you're actually going to include the VLF experiment, then you need a plus or minus 15, but a very small plus or minus 15. Very small. Once you know the voltage, now you build voltage. Your standard battery is 1.6 volts. That's what a lithium-ion battery produces. You produce bigger bigger stacks, bigger batteries. The term battery actually refers to a collection of cells. It's as in a battery of guns. That's where the word comes from. And so it's the tubes that reminded people of the artillery all pointed. I'm serious, because all of this was developed during World War I. The
Yeah, I think yesterday or the day before was the centennial of World War I.
no, it wasn't the centennial of World War I. It was the centennial of the assassination. It took a month for war to be declared. War was declared serially between July 28th and August 4th. Remind me, sometime around August 4th, I have to send Sir Edward Grey a memo.
Sir Edward Grey?
He was the British Foreign Secretary in August 1914. Another failure of the education system.
Well, that's great.
No, that's world history. And okay, maybe if I give Sir Edward Grey's most famous quote, you'll realize, oh yes, I have heard of him. The lights are going out all over Europe. They will not be lit again in our generation. That was Sir Edward Grey when he signed the declaration of war on August the 2nd, 1914. So you have to send a memo. Dear Sir Edward, the lights are on.
I'll be back. I have to go really quick.
Okay, so once you have your voltage list and you know how much current you're going to draw, then specifying the battery is enough voltage but not too much, and then the capacity is the other number you want. The capacity is current draw times time elapsed. I've said this several times. I said it long before that when I put that big chart up on the board. And the third item besides voltage and capacity is chemistry. There are two considerations there: minimizing mass and making sure you can transport it. Transporting lithium batteries turns out to be a fun game. Now, you can put as many as you want in your car and schlep off to New Mexico. It's getting them to Alaska that's going to be fun. Because a lot of people assume that we have a professional shipping department. Yeah, right. You go to the shipping department and ask for DOT certified lithium-ion battery transport containers, and I've got a couple over there. They're black things. They just look at you like, what?
A little bit of jewel hanging out of their mouth.
What?
A little bit of jewel hanging out of their mouth, just like, yeah.
They assume you're up to no good.
The idea that they're supposed to be a significant component of a professional research team has never crossed their tiny cracked brains. And I used to go to the trouble occasionally of actually buying them, liquor and cigars. And one time when they did a really good job, I even sent a memo to the Vice President of Finance saying this man deserves a promotion and a raise. I got really good service for the next year or so, actually, after that. That was widely considered a good move. But ultimately, they aren't very professional. And of course, my standards of professional are, well, NASA. Oh, you mean you want to ship a Saturn V across the country? Yeah. When do you need it? Expedited? Or actually, some people who really appreciate the quality of the shipping department of NASA feel like you could probably establish a moon base by simply specifying that as the shipping address and sending it to the shipping department. Some of the guys in the shipping would go, yeah, we can do that, yeah. It's just a budget question. Okay, this week, after all that done, and I'm really concerned about that 3.6 volt regulator. But I'm also concerned that I'm still asking questions like, what are the voltages required? And people have to look that up. Why are we still looking that up? Those numbers should be in everybody's head. Except Diego. He thinks the weather shield only functions with the 5, which is kind of interesting. I have trouble grasping how that could be. No, but
No, it has a supply voltage. Yes. It actually has 3 because there's 3 different components, so I'm about to add them all up to find the net.
no, you don't add the voltages. Each voltage is separate if they're different.
Yeah, they have three different supply ranges. One of them is -5 to 6, another one is 1.5 to 3.6, and the third one is 1.62 to 3.6.
So will you just increase the range from the lowest to the highest?
No. The voltage doesn't vary. Those are the allowed voltages. You pick one and stick with it. Now, what this does is, the fact that it is a range, is it lets you, 1.5 is one cell. 3.6 is, 2 fat ones. Now, since it's a range, it means you don't have to regulate. So you could put 2 cells in a battery, and you're going to be doing this with your own soldering iron, and what were they?
1.5 to 3.6, 1.62 to 3.6, and -0.5 to 6 volts. The recommended for that one though is 2.5 to 5.5.
Okay, so clearly what they're saying is the 1.62 as the minimum, since that's the top end of one cell, they're telling you, no, we don't want just one cell, we want 2. Former power systems engineer reading the real message there. So that one will work with 2, and they'll both work with the same one. So you just add up the currents.
Okay.
You don't add the voltages. You add the currents. Now the negative one, somewhere between the negative one, they want a 3-high stack. They want 3 cells in series, and the question is, how much current does it draw?
It depends on what it's doing. Some of them require 5. What's the funky U metric? Nobody can. The funky U metric. What's
The micro.
the microamps? One of them, the range is 5 microamps to 520 microamps. It depends on what it's doing.
You mean it's not just always measuring? There's a cycle of some.
Yeah, there's 3 different modes that it can vary in, and that was for the luminosity sensor.
Each individual sensor.
Because that's what they are. Is each individual sensor has its own individual data sheet, which confused me to no end. But
I'm still pretty sure that it doesn't need an external power source. I'm kind of big on this. If it's like a shield, then it's offering up the Arduino power source.
Where's an Arduino?
Right. I have one right here.
thing is in Arduino with enough power to power it.
Yep. Let's see here. Okay, so this has a 3.5, 3.3 and a 5-volt pin. Now, this is not a mega. The negative one bothers me. Um, so the positive presumably can come from the mega. The mega may have a negative output pin, or you may have to actually provide it. Somewhere in the documentation, it's going to tell you that there is no negative supply here. So now, I guess the question really is, then, if those are the sensors, somewhere there's got to be a document that says what the shield draws with the sensors plugged in, because it's entirely possible, and in fact possibly even probable, that the shield will have although producing a negative voltage means a DC to DC converter.
Oh, here it is. 3.3 volts to 16 volts. That's the whole shield.
The whole shield?
Mm-hmm.
And that's all.
Yes, that is all. It doesn't tell me anything about current.
Yeah, the current, somewhere it's got to. It's got to.
Is there a resistance or a wattage?
No. The only 3 data sheets are for the 3 individual sensors, not for the actual shield itself. The actual shield itself is 3.3 to 16 volts, and I don't.
It's got to give you it's got to give you a wattage or a current. Maybe not. Maybe you do need.
Can I find that on a schematic?
No, it should be right there on that data sheet. Maybe you need to get with the manufacturer and say, how much current does this sucker draw?
The mothership itself.
Huh?
It has 3 data sheets for the sensors on board. And it itself has a dash.
Yeah, it does not itself have its own data sheet. Yeah.
There's got to be some documentation.
The only way I'm getting 3.3 to 16 volts is from the web page that says, hey, this is what it does, and then it doesn't tell me current.
Then you have to ask somebody. We have to send an email, or more importantly in this time frame, a telephone call to the actual vendor. I find it inconceivable they would not provide the power consumption information somewhere. But if it isn't in the documentation, then we need to be much more. This is information we should have had weeks ago, like within a day or two of placing the order. As soon as you decide you're going to include a piece of hardware, you better be damn sure you know how to power it.
Yeah, probably. I have to call them. I don't see it anywhere.
Who did we order it from?
Rock Fun.
Who manufactured it?
It says it's an Arduino shield, so I believe Arduino manufactured it.
Try this. Google it. Weather shield current requirements.
There we go. You got that? My computer can be slow.
You just look at the weather shield. All it has is the 3.3 plus 3.3 volt and the plus 5 volt pin. It doesn't have anything else on it. I mean, it has a bunch of other pins, obviously, but no other power requirements.
Yeah, well, the 3.6 and the 5 are standard pins here.
Yeah,
That's
what I'm saying.
But this sensor has a negative voltage requirement.
Oh, there we go.
I'm
I
pretty sure
see
that in
that
that
here.
case, the weather shield itself takes care of it.
Well, you should be able to tell that from the schematic of the weather shield.
Do you need me to open the schematic for you again?
We might have some.
Do you know how
I would not be able to tell.
Oh, well, that's for the whole system. Everything.
Oh, that's fine. An Arduino plus weather shield power draw is a really good number.
39 million.
39 milliamp voltage.
I'm seeing 5 and 3.
3.3. 3.3 is regular.
Okay. That's coming off of here. This board produces that. But what are we pumping in here? Why is this so, at this point in the game, why is this so hard? You guys should be going, because we're flying in a month.
I'm using a lithium potassium battery, and it goes 4.2 volts fully charged.
Who are they?
We were on this. It's a Spark Fun tutorial set. Where it shows a demonstration how the weather shield works. How it's
So when you say 4 point, is that for the Arduino as well as?
yes.
I would think the Arduino required a minimum of 5 volts. I thought
That is the maximum that you can take. Otherwise, it fries if you go over that.
people have been telling me up to 7 in this room. Right? I've sat here and heard Abdul say, we will power it with 7 volts.
They're using a 3.7 6,000 milliampere hour lithium potassium battery.
I'd like to see it, but by the way, that would probably be good for the transmitter, except that we need to see the what? No, I'm looking at the time profile of the voltage.
Okay.
The time, I mean, is that really a regulated voltage, or is that the actual raw chemistry producing
That
that?
is the raw chemistry.
That because that will the transmitter might not be happy with that. We need to actually see the curve, and we need to get some information from that transmitter vendor. And other issues, I think it has been dealt with, but I haven't signed it. The connector to power the transmitter. The connector between the transmitter and the antenna. Excuse me?
It's the connector to the RF.
Oh.
Oh, my bad. I'm gonna just go. Yeah, we haven't ordered that yet. That hasn't been ordered.
Okay, the transmitter takes connectors. The connector, I mean, I even said this before it was ever ordered. I said, when you order the transmitter, be sure and order the connectors right then. Why did nobody do that? That's tomorrow, okay? The transmitter has 3 connections. The data in, which is RS-232, and you have to get what, that may go in on the USB port on this transmitter. Somebody needs to look at the documentation. It will tell you. There is a connection out to the transmitting antenna. I believe we ordered an antenna. Someone tell me we did? Okay, now the question is, do you have the connectors to connect the antenna to the transmitter?
That was not.
Why not? I mean, does anyone understand why I'm just going ballistic with frustration? These obvious pieces that are just being omitted?
Apparently they're not obvious to us.
That you need to connect to things?
Yeah. Maybe whoever ordered it assumed that the connector came with the antenna, and maybe it even does. Maybe they come with the connector. That's another thing. A lot of people that order these parts aren't exactly in the about why they ordered.
Okay, that's fair. But we do need to be sure we can connect. And it is true, it is probably the case that the antenna itself has a connector on it, and it may well be the case that that antenna actually mates to the transmitter if you can put them together. But we may not necessarily be in a situation where we are going to do that. We need to be able to have a cable in between, which means we have to order some connectors or check that we have them. There is now, quite often on these transmitters, there was one lying around here. Or is it still here?
Heavy one, slightly heavy. I haven't seen it in a while. It's a box.
It was about this big. The signal in and the power in come in on the same connector. It's a fairly specialized connector. It's a bayonet type mil-spec connector. Now, if the power is coming in on a USB, then that's a separate issue. But we have to have that connector. We're dead in the water without that connector. Now, it is also possible that the transmitter comes with one. But we need to know. And if it doesn't, we need to have, it should have been ordered at the time. I guess I can see that people don't know necessarily that these things, you have to order the connectors. They don't necessarily come with them, but
Yeah, unfortunately, we take for granted that connectors come with devices.
not true when you're doing original equipment manufacturing. It's absolutely not true. You cannot take that for granted. You have to ask. And it will say in the description of the parts you're ordering. It will tell you. They don't keep it a secret. And if it doesn't say it, it's not. You can't make that assumption. You have to look at the list of what you've ordered.
Understood.
Actually, the problem is that people are not thinking in system terms. You go out and you go for a part, but you don't think of how does this fit in the system, and ask. But you've got to think in system terms. We don't have that much time. So we got to be sure that all the pieces of the system are on their way this week. And we may be dead in the water because most things take 4 to 6 weeks. Okay? I mean, the inordinate amount of time it's taken since we decided to have this test flight to get some of these very basic things is just, well, it's a surprise to me, but it's really getting to be crucial. The battery should have been ordered a day or so after we ordered the transmitter. Because once we had the transmitter ordered, we knew what the voltage was, we knew what the current was. And so you're saying that the Arduino draws 39 milliamps total at 4-point-something volts?
I'm not sure I agree with that.
That seems awfully small.
I was just looking at the specs of the Arduino itself. Arduino, I think the voltage, like the input voltage recommended is 7 to 12.
See? It isn't 5. Although, when you power them this way through the USB port, you're powering them with 5 volts. That's the voltage available at the USB port.
I must have been thinking of my system and how it because with my system, when you connect the solenoid to the Arduino, you have to have a buffer between them because supposedly the backlash from the solenoid will fry the Arduino. That's why I came up with the idea of
Um, uh,
The operating voltage is 5. Okay, here's a problem.
the your solenoid shouldn't be anywhere near connected to the Arduino. Things like that shouldn't be on the same circuit with a computer at all.
correct.
Um, if you need to apply power to a solenoid from a signal driven by a computer, that goes through. Geez, I might even use an optical isolator to really be sure. You want to have a relay driver circuit and a separate battery driving that solenoid.
That is I am currently building the circuit for that. I have a separate battery, separate relay, the solenoid only being controlled by the Arduino, not being powered.
And you do need to be very careful about buffering that. I mean, the belt and suspenders would be an optical isolator.
Can you repeat that term, please? Belt and suspenders.
Belt and suspenders?
No, you said built-in suspenders.
I said belt and suspenders, as in the very conservative engineering approach, wearing a belt with your suspenders.
Oh, okay.
I'm sitting here going, face palm, you need that repeated?
I thought I misheard that.
I definitely agree. I did too. I thought you were talking about
I was
somebody-
confused about why you were saying belt and suspenders when we were having an electrical
about belting
conversation.
with the-
Oh, belt and suspenders as the metaphor for being very conservative in your approach to engineering.
Yeah.
Actually, it's probably not a girl thing.
No, I don't think I wore suspenders since I was like 9, when it was the 90s and overalls were cool.
Well, you have an anatomical reason why you don't need them.
Yeah.
Whereas if you're my shape, it's inevitable. And I discovered why you wear a belt with suspenders. It keeps the buckles closed. You do not need a belt with suspenders if you're wearing button suspenders.
The more you know,
Hmm?
the more you know.
So, anyway, the carefully conservative engineering approach is an optical isolator. Now, that's probably gross overkill. I've never used it. I've just used a two-driver circuit and a separate battery to power the relay. And so definitely, and we need the transmitter battery, a regulator if the battery isn't regulated, or maybe you want to talk to the transmitter vendor. If there's a 3.6 volt lithium-ion stack, the question is, will that transmitter tolerate the intrinsic time variation during discharge of that? It's pretty flat, but it's not zero. And so you need to actually ask the transmitter vendor, hey, will this lithium-ion battery unregulated kill your little baby or not? But we're running out of time, guys. Because this isn't that hard. You get the current, you get the voltage, you know the time. Current times time is the capacity. Voltage is, okay, most chemistries give you 1.5 to 1.6 volts. So you now know your cell size. To make an actual battery, you stack them up with a soldering iron. And there are commercial batteries that are sold, like the one I have in there for the camera. That's so once you know what the voltages are and the current that's being drawn, I guess I'm
as soon as you said multiple batteries, I got a good picture of them. I was thinking we need to buy one battery to power everything, but if we're getting different batteries, I mean, we're gonna have a power. Or are we gonna have a box on this payload that's like just for the power?
That depends
Okay.
on how or what works best.
All right.
I mean, so probably not because that.
Okay.
I mean, and quite often individual experiments have their own batteries. Like the batteries for the VLF probably are going to go around with the VLF because the Arduino doesn't need plus or minus 15.
Okay.
Except maybe if we have a plus or minus 10 ADC, somewhere in there there's a plus or minus 10, plus or minus 15, 12 at least power supply kicking around. At this point, you guys are scaring me because a lot of this stuff should be a lot better nailed down than it appears to be. You know, it's these are numbers that should be in a table in the PDR presentation by now. And the fact that I'm still not getting clear pictures on the Arduino power draw and voltage. So, okay, let's pick 10 volts. If we have actually. Let's go with 9, because that's six cells deep. What's the current draw on that stack going to be? The Arduino plus the weather shield. What's the Arduino by itself? How much current does it draw?
You have a spec sheet.
Okay, who here is actually on the power team? You guys should know those numbers. That is the fundamental number. I should be hearing 23 amperes coming right back at me.
40 to 50 milliamps.
Okay, so 50 milliamps. So to power this sucker for 10 hours, you need a 500 milliamp hour battery. And in all probability, since we are going to use conservative engineering, you want a 1,000 milliamp hour battery. If you could tolerate 5 volts instead of 7, there would work perfectly. It's 5,000 milliamp hours.
Okay.
But okay, we've just established what the battery needs to be. A 1 amp hour, 1,000 milliamp hour, 9 volt battery, minimum weight. Now, it could be somewhere between 7 and 12. And the only remaining question then is, do you need anything else to power the weather shield?
I say no.
But no. The fact that we can't, the fact that you keep coming up with this minus voltage is.
It says that's what it says on the data sheet for one of the sensors.
Look at the schematic, boys and girls. Or should we go? Well, we can't because I guess we can because I can stop broadcasting right now. We can go stare at it. There will be connections that are labeled on it.
The only voltage connections that I see on it are plus 3.3 volts and plus 5 volts.
Oh, there's one more. It's 2 pins over from the plus 5. It's VN.
Wait, I'm looking at the weather shield. Is that the weather shield?
No, it's the Arduino. This is what it connects to.
Well, it has VN and it has ground.
VN is that 7 to 12.
Okay.
But if one of the sensors takes negative voltage, then somewhere on that schematic, you're going to see a DC to DC converter.
What are Eagle files?
Hmm?
What are Eagle files?
I have no idea. Probably some sort of compression. You know, this is why I like to do things with paper, folders, and books. More than one person can look at them. They don't take as long to call up because it's all already been called up.
The only thing I'm seeing on the light sensor, which is the one that would have had the negative voltage, is a 3.3 volt
Hmm?
thing. Not sure what to call that. Is it-
Let's go stare at it. But
Is that connected to the printer?
No, I can. But
I'm not sure if the weather shield is in here because I don't have it for it.
no.
Or is this it right here? This looks like
This
it
is
right
it.
here.
This is it.
Okay.
The light sensor was the one that would have had the negative voltage. The other ones were normal.
We put the weather shield in there.
okay, so the Weather Shield power system takes a maximum of 16 volts, but it works on 3.3. Dear God.
Yeah.
The it's drawing +5, so it has it does have its own raw power coming from somewhere. There may be a place. Oh, there's raw VN. Okay, that comes in through the VN pin. The
It does need its own power.
hmm?
It does need its own power.
I just said the opposite.
VN pin. That means it comes from the Arduino.
Okay.
So we can power the Arduino, but it'll power everything else.
The VN pin in the Arduino is connecting to the
Yeah.
pad labeled raw and the rest of the circuit. Guys, um, there is some sort of a serial select switch, does something with the GPS. Rain, optional.
We don't have that sensor, I don't believe.
Conversion. What is the sensor that takes negative voltage?
The light sensor below the rain, the optional rain sensor. The blue small plate on it there.
It's not wired that way. It's wired to plus 3.3.
Yeah.
Okay, so this does not. This is powered strictly from the Arduino, and the question then is, nah. these people obviously don't care anything about total power drain because they don't conceive that this would be used. Okay, here we go. Oh God, they are giving it to you sensor by sensor, aren't they?
Mm-hmm.
What you have to do is simply add up the currents. But if they're measured in microamps, we don't really worry. I mean, this, if the, I suspect this doesn't add much of anything to the power draw of the Arduino. So we have one battery for the Arduino with the weather shield, one battery for the transmitter, the 12 volts for the relay driver, and that is all you need if we don't have any other experiment. Rachel will need plus and minus 15. But at about the probably 20 milliamp level, I would guess. And we can pare that down if we have to.
Clarify, plus or minus.
Both. I mean, it's exactly the same as your circuit.
Hey, I was making sure.
Your circuit's going to be running on plus or minus 15, plus and minus 15.
Right. Plus and minus. There you go. Okay, that makes sense.
I guess we don't need to go stare at the Arduino.
It's in here anyway. That was the weather shield.
Weather shield. You're violating the rules.
Yes.
Is this it?
Not right.
Oh, I see the rain and wind are optional sensors, and yeah, we need to get extender cables because this is going to be, maybe 3 or 4 inches. This obviously is not the kind of shield that would power the sort of sensors you have on the iNet. Somehow, this is a disconnect because I remember Erica came in and said, is this what I need to go with this? And was looking at boom-mounted sensors that go from some other vendor. And if you're going to use those, there's probably another shield or you'll have to make a shield. What, you asked them, can we make our own shields?
Yeah.
I was sitting there saying, God, I hope so. But I don't know how to get there. Yeah, I mean, we are going to have to figure out how to do surface mount soldering. And I can't believe the campus doesn't.
No one's going back. Dr. Yeah, it was Charleston. Dr. Charleston had me email me back about the circuit like layout software. So,
Yes, he has.
yeah. I sent him the email with my password. I saw it.
And you got an email back about 2 days ago. It came to me, too.
Was it the one where he didn't have to? He asked me about. He said password is wrong.
No, I've established all the accounts. Here's how you do it.
Oh.
Did you get that one? Okay, and maybe that he hasn't done your account yet, but I haven't figured out how to do that. The instructions he gave me were for if you actually log in directly using. I gotta figure out how to do that. All right.
Okay. If anybody had a check, then check.
I get you.
Okay.
Okay, well, I'm going to kill this and